Hi, my name is Alex Su. I'll be going over with my midterm ECE 301 lab. So as you can see, the requirement is using prime numbers. Prime numbers are the whole number that's greater than 1 and only can be factored by 1 in itself. So for instance, will be 2, 3, 5, 7, 11, 13, so on and so forth. And when we design the circuit, can only be in and not gate. So that's also the requirement. So let's go ahead and go over my truth table. So as the format suggests, it's 0 to 7. So, and I also mentioned that prime numbers are 2, 3, 5, 7. Those numbers can be factored by 1 and itself. So that includes 2, 3, 5, and 7. Since these are the prime number, they will be 1. So 0 with the first one, 0 will be 0, 1 will also be false. Only the prime numbers are true, so 2, 3, 5, 7s are 1. Next, let's go over my K-map. So we have A as the column and BC as the row. So I have A prime A, B prime C prime, B prime C, BC, BC prime. And when we go ahead and draw the K-map, it results to AC plus A prime B prime, and we can go ahead and use the Boolean expression to verify that. So as we mentioned, we're going to use 2, 3, 5, 7, and that can be written as m sub 2 plus m sub 3 plus m sub 5 plus m sub 7 will equals to this whole equation. So for m sub 2, that will be 0, 1, 0, and the results will be true. So since it's 0, it will be A prime, and B will be true, so that'll be B. C 0, so C prime plus etc. So m sub 3 will be A prime B C plus, for the m sub 5 will be A B prime C, and for the last one m sub 7, it's all true and results will be true, so ABC. And when we go ahead and factor it out by taking the common letters for this first two expression right here, which is A prime B and parentheses with the remaining, which is C prime plus C, and this two expression, which is AC, which they have in common, and the remaining will be B prime plus B. And as we know, C, any prime and non-prime added together will be 1, so it will be remaining to A prime B plus AC as the Boolean expression. And we'll go ahead and go over the circuits diagram with NN and NOT gates only. So we already know that it's not focused. There we go. The function is equal to A prime B plus AC. So what I do is this times and plus, that means they are AND and OR gates. So we have to actually convert to AND only. So by doing so, we can add additional primes onto it, so the plus will get converted to times. So overall, if you have double prime, that can be canceled out to just no prime. So false false equals true, so on and so forth. That's based on the De Morgan's law. So if you have a prime times b prime will be a prime plus b prime, and if you have a double prime, that will be just a. So if we do so by having this expression that only contains in and the a prime, which we have to put a not right there, times the b, so b, it will be in AND gate, so that's right there. And we also need AC in prime, so not. So when they combine, it will be this equation right there, and this equation is also true to the function that we found earlier. So once we have everything, let's go ahead and test it out along with our truth table. Let me zoom out. Okay, so it's already power on. So this is my not, and this is my AND, and from, let's make it all true. So when we have all true, all the A, B, and C, and the F shall be 1. And when we have all false, should be no light at all. So let's start with 0, which is this current stage, and the next one will be 1. That should also be 4, and let's switch C to true, so nothing lights on but C. Let's do the second one. 2, this one should be true when we switch B on, so B is on and the function is true. Let's do the numbers 3. Having B and C to be true, the function should also be true. When we have A true but B and C are false, the function is false. And when we have A to be true and B false but C true, then the function should also be true. And when A and B are true but C is 0, then the function should be false. And finally, when we have A, B, and C to be true, then the function is true. So that concludes my ECE 301 lab midterm. Thank you.